Welcome, fellow chemists, to the third and final part of the Introduction to Alkane Nomenclature, where we finally encounter molecules with functional groups, the alcohols and the amines. Check out parts 1 and 2 if you need a refresher. When there is an alcohol group present, the parent hydrocarbon must contain the functional group, OH. So for these examples, the first option winds around to reach the functional group and is only 5 carbons long. The second path goes straight for it from the left and is 6 carbons long. So we will pick this one as the parent. This means that hexane will be part of the name for this molecule. Once you have identified the parent, you will want to ensure that the functional group gets the lowest number possible. In the case of OH, you will refer to it as all in the name. So using the previous molecule as our example, the OH is all, and that is our functional group suffix. The parent is hexane, but as is convention, we remove the E at the end to name it hexane. The remaining alkyl substituent is propyl. Like the ether at the end of the part 2 video, the OH is all the way to the right and will be position 1, meaning the propyl group is at position 2. We have now identified everything we need in order to name this molecule, and it is 2, propyl, hexane, 1, all. If there is a tie between the functional group and some other substituent on the molecule, the functional group gets the lower number. If you remember breaking ties because of the alphabet, you know the general idea here, so give it a go and name this molecule. The parent hexane, or hexane, is pretty easy to identify, and so is the chloro substituent and the alcohol group. The numbers from the left are 3 and 4. Switching sides, we find out the numbers from the right are also 3 and 4. We want to choose the direction that gives the alcohol the lower number, so we go from the right and give it a 3, and so the chloro gets the 4. Therefore, the molecule is named 4-chloro-hexane 3-all. If the functional group gets the same number regardless of the direction, ensure that another substituent gets the lowest possible number. This idea should seem pretty familiar to you by now, so try naming this molecule. The parent of this molecule is 7 carbons long, or heptane. The alcohol is directly in the middle, and there are 2 chlorine substituents on the adjacent carbon. Since we have 2 of the same substituents on this molecule, we need to utilize the prefix di for them. Finding the positions of these substituents from the left, we get the alcohol on position 4 and the pair of chlorines on position 5. When we find their positions from the right, the chlorines are on position 3 and the alcohol remains on position 4. Since we cannot possibly give the alcohol a smaller number, we want to ensure that the chlorines get the lowest number, which in this case is the 3. So we have a molecule where the functional group does not receive the lowest number in the name, which is 3,3-dichloro-heptane 4-all. When there are multiple substituents on the molecule and a functional group, continue to list those substituents alphabetically. This is the first time we are going to see a functional group on the ring structure, so try pausing the video and naming the molecule. On this molecule, we once again see a cyclohexane ring. We also have our alcohol, ethyl, and methyl groups on it. On a ring, we want to give the alcohol position number 1, and then number accordingly from there to generate the lowest possible set of numbers. So starting clockwise from our OH, we get a 1, a 4, and a 6 for the locations. Checking the anti-clockwise direction, we get the numbers 1, 2, and 4. So it is pretty clear that the anti-clockwise direction gives us the lowest set of numbers, which we will use in the name. With everything identified, we develop the name 2-ethyl 4-methyl cyclohexane 1-all. Now for a different functional group, and we are joined for the first time by nitrogen. We will include the amine in the name and if necessary, use the letter N as a location. If there are no substituents on the nitrogen, the rules are exactly the same as they are with alcohols, so try naming this molecule. For this molecule, we have a pentane, or pentan, parent, a bromine substituent with our amine functional group. We want to give the amine the lowest possible number, and if we find the locations from the left, the bromine gets a 3, and the amine ends up receiving a 4. But when we switch directions and count from the right, the amine gets a 2, and the bromine gets the same number 3 as it just had from the left. We need to number from the right, so we give the amine the 2, and the bromine gets the 3 as we know. Now with everything identified for this molecule, we put it together and get 3-bromo, pentan, 2-amine. When there is a substituent bonded to the nitrogen, that substituent is assigned the position N in the name. We still want to give the amine itself the lowest possible number that we can. With that brief description, see if you can name the molecule on the screen now. Cyclohexane, or cyclohexane, is our parent ring. We have an amine group, and on that amine group there is an ethyl. The ethyl is bonded directly to the nitrogen, so we can automatically give that the location N. We also have 2 methyl groups on our ring, so we will need to use the prefix di for them. As the amine is a functional group, we start the process of determining the positions from that as number 1. Starting from the amine and going clockwise, we get the numbers 1, 2, and 5. Switching directions and going anti-clockwise from the amine gives us 1, 3, and 6. So we are going to pick the clockwise direction for our numbers. Even though its position is not noted with a number, ethyl is still first alphabetically, and we get the name N, ethyl, 2,5-dimethyl, cyclohexane, 1-amine. To summarize the final set of rules for the alkanes, the parent hydrocarbon is the longest chain containing the alcohol functional group. Ensure the functional group receives the lowest possible number that it can for its location. When there is a tie between the functional group and a substituent, give the functional group the lower number. If the functional group gets the same number from both directions, ensure another substituent receives the lowest possible number. Continue to list the substituents alphabetically and place the functional group suffix "all" at the end of the name. For amines without a substituent bonded to it, all the rules we just saw for alcohols apply. And finally, when a substituent is bonded to the nitrogen, it gets the location N and apply all the other rules to finish naming the molecule. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. For today's recommendation, I have to go with Crash Course. Not only will you find a full general chemistry playlist, but they are currently in the middle of a 50-video long organic chemistry course. You'll find links to the channel, playlist, and website in the description. Of course, you can find additional organic chemistry content here by checking out a couple of my previous videos on the nomenclature of alkanes. Please feel free to get in touch with me via email, social media, or if you would like, make a request in the comments.